I'm just doing it a little at a time because you know what it is.
Well, yeah. You can only force people to do so much. Okay, we gotta get our life right. Sorry, I got off track. I need help finishing this barrier, and then we need to do these notes quickly so you can get to your assignment so we won't be days behind rather than 1 day behind. When I distribute that 5.3 to the 5, what do I get? 26.5?
Yeah.
Okay. Okay, and then when I distribute the 3, I got 3 plus, I don't know what 3 times 3.5 is.
5e minus 2.98.
Okay. I would then combine the like terms.
2.98.
2.98, my gosh. Okay, then I would combine those like terms, and I would have 5.3v minus 26.5 equals 10.5v minus 0.02. 0.02. Agree. Because 3 minus 2.98, you have barely anything left over. Okay, now what?
You're done. Could you put subtract 5.3 on the
Sounds great. So let's subtract 5.3 on both sides. I would have, and I'm going to go to the top because I'm out of room. Maybe you wrote tiny to me. I don't know what you're doing. Deal with it. Okay, we left some room above. Maybe you can squeeze it in there. Negative 26.5 equals, what's 10.5 minus 5.3? 5 point what?
2.
Okay, now what? Now what? Tell me again. Now what?
You have to add point.
Okay.
To the other side.
But I've done something wrong. My sign's wrong. Shouldn't that be a plus? 3 minus 2.88.
Yeah,
3 is
plus.
bigger. It should be a plus. So I need to subtract. So I need to subtract 0.02. So I have something equals 5.2v. What is the something?
Negative 26.52.
Okay, and then divide both sides by 5.2, which I can't do because Lord knows I'm out of room for real this time.
Negative 5.1.
Yes, I know the answer is negative 5.1. And I don't know why we did this. I'm just happy that the Belgrade get made, so I don't know why I'm complaining. I didn't have to make them. I should not complain. But I don't know why the second one is always, the right one's always easier than the left one lately. It's interesting. On the right one, let's do it fast. If I combine like terms, I'll have 10w plus 6 equals 7w minus 21.
Yes.
Wait, why didn't you combine the others then?
Because they're not on the same side.
They're not on the same side. If I subtract 7w,
And get 3w.
I'll have 3w plus 6 minus 20 equals negative 21. So if I subtract 6, I'll have 3w equals negative 27. I end up divided by 3. I get w equals negative 9.
Negative 9.
Let me zoom in on that. Okay, yesterday I was bleeding a blonde, and we're all allowed to have our blonde moments overthinking my life. Today we're going to fix my blondness. You need out 5 colors at least. If you don't have colors, you know there's markers in the back things. If you want, because I'm going to do all the graphs on the one card, hence the colors. The first thing I'm going to do is draw a big coordinate plane again. Okay, if you don't have 5 colors, it'll be okay. Let's start with the beginning. We talked about yesterday a square root function. What is the parent function of a square root function? F of x equals what? We did that. The standard form was the square root of x minus h and the plus k. the parent function is going to be the one who has a vertex at 0, 0. So it's not even going to have an h or a k listed because there's no need to put x minus 0 plus 0. So it's just square root of x. Okay, so basically I want to fix what I did wrong by graphing these 5 and looking at them. So the first one I'm going to graph is the parent function, y equals square root of x. So we know the vertex is at 0, 0, so I put my first point at 0, 0. Then most of what I said yesterday is completely true. So because we know the square root of 1 is 1, my first point is at 1, 1. And I know the square root of 4, 1, 2, 3, 4, is 2. So my second point is at, or my third point really, my next point, let's just say next. My next point is at 4, 2. Again, I know the square root of 1, it is 1. I know the square root of 4, it is 2. And if I wanted to keep going, what would my next point be?
9.
Yeah, because I know 1, 2, 3, 4, 5, 6, 7, 8, 9. I know the square root of 9 is 3. 1, 2, 3. So I put my next point there. So my pink graph is my parent function. It looks like an arm. To me, it looks like an arm. Nah. Okay, if we had to, and we didn't even talk about this yesterday, if we had to list the domain and the range of this graph, what would you tell me? It's all numbers that are what? For the domain. They're on a specific side of the graph. All the numbers have to be what kind of numbers?
Positive.
Yes, so they're all greater than or equal to 0. That's how I'm going to list it. If we were doing bracket notation, I might say like 0 to infinity, but we'll just do it with interval notation today. Okay, what about the range? Those y values. Tell me about those y values. What are they? They're all positive, negative, any kind of numbers. They're all negatives? They're all down here?
They're positive and negative.
They're positive and negative. You see some down here on this negative.
They're positive.
They're all positive as well. For the domain and the range of a square root function, all the numbers are positive. All positive numbers. If this is our parent function. That's a big if. What we did yesterday, and we're not going to do today, what we did yesterday was shift that vertex around. So if we shifted our vertex to like over here, would that change? Well, yeah, because then apparently on the y we can go all the way to -2. And on the x we can go all the way to 1, 2, 3, -4. But if this is our parent function, that pink graph, then yes, all the domain and range are positive numbers. Okay, but we got to fix what I did wrong yesterday, so trying to... Not that there was nothing wrong. There's nothing wrong with when you're stuck. Let me rephrase all that. When I get stuck and when you get stuck, is it a good idea to plug values in and figure points out? Yes. So should I plug in a 4? Square root of 4 is 2. 2 times 2 is 4. So I go to 4, 4. Yes, you should. That's not a bad idea. Nothing, after I fixed it, after the second time we did the nose, there was nothing wrong with that. But is there an easier way? Of course, there always is. There always is. Okay, let's do number 2. I'm going to use a different color. What is the vertex of number 2?
2.
The vertex of number 2. It's still at the origin. The h and k are still 0. In fact, on all 5 of my examples that I'm picking today, notice I'm not changing the h or the k. So we talked about yesterday if it was like 1/3 x minus 6 plus 2, then our vertex would be at 6, 2.
Okay, I have a question.
But I'm not doing that today. I'm not. I felt like you understood that well yesterday. I'm letting go of that today. Ma'am.
Okay, so when you have that +2 right there,
Yes.
it's not under the house. Does that mean something different?
Yes. So the not under the house has to do with the y. The under the house has to do with the x. Kaylee yesterday. So, you know, I know you picked up the worksheet on your way in. You know I'm going to let you work on that when I get done rambling. Kaylee yesterday made a mistake on Desmos, which is one you want to be careful with. She accidentally put the 2 under the house. If it's not under the house when you're typing in Desmos, be careful and make sure you don't put it under the house or suddenly your graph's going to change. Okay, so for my second example, we know our vertex is here. And then where you're like, well, Miss Compton, can I not do this over 1 up 1, over 4 up 2, over 9 up 3? Is that not going to work? Yeah, so we're going to have to talk about that. So the 2 would be over 1
Up 2. Or over
and up
2.
2.
Oh, okay. And then
Are you sure? I'm right.
Yeah, I know I'm right, because if I plug in a 1 right now, I would have square root of 1, which is 1. 2 times 1 is 2. I got my life right. It took a while, but I did. And so on our parent graph, we had gone over 4 and up 2.
But you gotta go over 4 up 4.
Yeah, but we're going to go over 4 up 4. And why? We take what we did, and we're multiplying by 2. So it used to be over 4 up 2. Well, 2 times 2 is 4. So I'm going over 4 up 4. So it used to be over 9 up 3. What should this next point be?
Over 9
Up.
6.
It should be 4, 5, 6 is off the graph. So I finally got my life right. I remembered how to do math. Thank God. It was getting a little hazy there. I was questioning everything in my life. Okay, is everyone good on number 2?
Yes.
I want to skip to number 4. Why am I skipping to 4?
Because 3 is a half.
Yeah, so I'm going to save the 2 fraction ones because I bet they're going to do something a little different. So let's go ahead and do the other whole number one. Okay, still origin is my vertex. But instead of going over 1 up 1, I'm going to go over 1 up how many?
Half.
3.
Oh, wait.
My,
Look
at my number.
5.
It's a 5, so I'm going to go over 1 and up
I don't know.
5. Square root of 1 is 1. 5 times 1 is 1. I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. Now, can you, if you're questioning yourself, still plug in that 1 and say, oh yeah, 5 times 1, that really is 5. I know it is 1, 5. Yes, you can. Is that what we were doing yesterday? Yes, we were.
Mine's going to go off the graph.
Mine is too. And so I was going to go over 4, and for the parent, we did over 4 up 2. Instead, I would need to go over 4 and up how many?
6. No.
You would go over 4 and up 10 because we multiply our number by the number on the outside. So instead of going over 4 up 2, 5 times 2 is 10. So it would be over 4 up 10. I get that's way off the graph. So another point would be over, so we went over 4. It used to be over 4 up 2, but 2 times 5 is 10. Again, if you're still questioning your life, you can always plug in that square root of 4. That ends up being 5 times 2, which ends up being 10. So for real, it is over 4 up 10.
Why do we go over 4?
I love to do the perfect square numbers, 1, 4, 9, just because I know the square root of 1, I know the square root of 4, I know the square root of 9. If we go to like 2, I don't know the square root of 2. It's going to have to be a decimal, and then we're never going to be crossing the whole lines. We're going to be in between, so I always pick the perfect squares. That's the best question. Well, I'd say it's the best question I had all day, but I had a really good one last period, so that's the second best question I've had all day. Geometry. You'd be like, I don't know what you're talking about, Miss Compton. That's weird. Okay, are we good with the first 3? Are there any questions about the first 3? Is our life getting better?
It's sure not.
Why?
I get it. I just don't want to do it.
That's true.
I just don't get it.
Okay, so let's go to the 1/2. We know we started the origin. With the parent function, we went over 1 up 1. But we're going to go over 1, and instead of going up 1,
Go half.
we go a half. Now, again, if you want to plug it in and say 1/2 times the square root of 1, well, that's 1/2 times 1, so it really is a half. I know I'm right.
What do you do with the half?
Go up half.
So with the parent function, it was over 1 up 1, right?
Right.
That number on the outside is what we're multiplying by. So instead of going over 1 up 1, I'm going over 1 up a half. Just like on our second example, or on the orange example, instead of going over 1 up 1, because the number was a 5, I went over 1 up 5. On our blue example, instead of going over 1 up 1, because the number's a 2, I went over 1 up 2. And if I were to skip to number 5, instead of going over 1 up 1, I would go over 1 up a third, because the number is 1/3. So,
Are
sorry,
you gonna go? Is it gonna be 4-1?
yes. So I used to go with the parent function, I went over 4 up 2. Well, I take 2 times a half, it's really just 1. You're going half the distance.
And then so it's gonna be 9 and 1 1/2.
So on this one, instead of going over 9 up 3, 3 times 1/2 is 1.5 or 3 over 2. So it is that. She is correct. Now, if you're still not liking it, can you still do, here's number 3, can you still do what we were doing yesterday where you plug in the perfect squares? Yeah, you can say, well, I want to plug in 1 because I know the square root of 1 is just 1. So I end up doing 1/2 times 1, which is just a half. So my point is 1 1/2. And if I want to plug in, let's say 4. Why 4? Because it's a perfect square. I would do 1/2 times 2, and I would get 1. So I go over 4, I go up 1. But what Ty's doing is counting it, and she's not having to actually calculate anything. So with my parent, I went over 1 up 1. But because of that half, I go over 1 up a half. With my parent, I went over 4 up 2. But because of that half, 2 times a half is 1, I go over 4 and just up 1. Instead of over 4 up 2, I went over 4 up 1. Instead of over 9 up 3, I went over 9 up 1/2. And if we were to do our very last one on here, with the 1/3 x, my origin is still my vertex, but instead of going over 1 up 1, I would go over 1 up a third. Instead of going over 4 up 2, I would go over 4 and up what?
Half. Right? Because if it was that 1, wouldn't it be half? Oh, wait.
It's a third.
1/3. Well, I'm confused now.
I'm on 1/3. Instead of going over 1 up 1, I would over 1 up a third.
So it's going to be up 4 over 1/6. Wait, I messed up.
Uh-huh.
1 over a third, but then a third times
A third times 2.
2/3.
So 2/3.
Oh, and then
A third times 3.
3/3. 4/3.
A third times 3
10/3.
is just 1. So what am I doing in my head as I make my graph? I know. What am I doing in my head as I make my graph? I'm thinking about my perfect squares. I'm thinking about how if I went over 1, 1/3, it's number 5. I'm thinking about if I went over 1, if I plugged in a 1, it would end up being a third. So over 1 up a third. If I plugged in a 4, it'd be 1/3 times square root of 4. So 1/3 times 2, which is 2/3. So that's how I got the 2/3. I'm taking my perfect square number and multiplying by that on the outside. Do you have to do it that way? No. Can you do it the way I'm doing down here at the bottom where I actually plug in a number, like plug in the 9, get out the 1? Yes, you can. You can always go back to what I'm doing at the bottom. But what we were discussing yesterday was there a secret trick counting method that you could use when it's a not equal to 1? And yes, there is. I was just being a blonde. It happens to the best of us.
I like to do all the rest of them, but the third one was the one that got me.
Yeah, you didn't like the third. So, you know, if you see fractions that aren't 1/2, you probably need to actually plug stuff in. Okay, so John David, hand me your worksheet. Your thing now is this. I don't care if you use Desmos. Obviously, you need to graph that vertex. It might help you if you list the vertex each time first. Like for the first one, the vertex would be 5, 0. So it might help to list that vertex first. And then my second suggestion would be, because, you know, life is hard and we forget things. Like Kiana was saying, yesterday we discussed the base form was x minus h plus k. It looked like that.
Plus K sugar.
Plus k. It should be a plus k. Thank you, dear.
Wait, is it not negative 5? Number 1? Oh, no.
Oh, you're right. I did that wrong, didn't I? Because it wasn't under the house. It should be 0, negative 5. Thank you, dear. I appreciate that. Because the number wasn't under the house, so it's the y. Good grief. I'm crazy. Okay, so what I was going to say before I got off track was, for instance, we have an issue with number 4. What's wrong with number 4?
There's the plus 4.
Yeah, what's supposed to be first in our base form?
The house.
The house. So we need to reorder that equation, make it this before you graph. So I would make sure they're in this base form order with the house and then the h and the k before I start trying to graph anybody. I don't care if you use Desmos. I don't care if you work with your friends. I don't really care. I just need it done.
Can you put your work back up there, please?
Yeah, I sure can. Okay. I need that thing by tomorrow, please. If you get it done now, awesome. John David's like, please hand me my work. Miss Candy. Miss Candy. Now we know what's really on her brain. Ma'am.